Hi guys, in this video I'm going to show you how to do the vector question. I have given the question in the PDF below, so you can always download that and try to do it in your own. After that, watch the rest of the video. Also, we have posted many videos regarding vectors. If you like to watch them, please subscribe our expert tutor. Okay, let's go to the question. So in this question they have asked about the vector orthogonal projection of two vectors. So first of all, we need to know what's meant by that orthogonal projection, otherwise it would be a little bit difficult to do this question. Okay, first of all, let's write the question first. In the PDF you can see this question in the first main section at the B part. Hope you have already tried this. After that only, please watch the rest of the video. Okay, let's start this. Okay, here they have mentioned there is a vector v1 1 2 3. They are given the coordinates of these vectors, and here they have given v2 2 minus 1 3 are defined in R3. What's mean by that? So some might confused with this thing, the r cube or r to the power 3, like that. The notation means actually we in this scenario we have taken the real numbers in three directions, x-axis as well as y-axis and z-axis. So we need to use the 3 over here, which simply means we have taken the real values in three axes. So that's the meaning. We have taken the real values only in these three axes. One is 2, another one is minus 1, another one is 3. So like that, we are going to take only the real values for that. So here they have asked about compute the scalar component of the orthogonal projection of v1 onto v2. So normally you knew that orthogonal means we need to have a right angle in that projection. So here they have asked to make a projection, orthogonal projection of v1 on v2. So here let's say this is a vector v2. So first of all, I have already mentioned, when you are approaching any vector question or any question, any type of question, if you have any diagrams, you can easily draw that. Otherwise it would be a little bit difficult to think on about that. So here we can just draw a vector like this v2. As they have given, the main point over here is they have only given the coordinates. Let's take it as there are two coordinates over here, which means in this line we can directly tell there is a point called the center point, which would be 0 0 0. From that point it's going to go through another point 1 2 3. Sorry, as this is a vector v2, we can directly tell it's going to go through a point 2 minus 1 3. So from this direction, the direction would be 2 minus 1 3. So we can directly tell the vector also going to be that point vector. In simple terms, we can tell they have taken this point from like this. Let's say this is a coordinate called 0 0 0. From that there is another point called 2 minus 1 3. This vector is passing through these 2 points. If you deduct these coordinates from these coordinates, you will be getting the vector direction vector, which will be which you will get as this same point vector. Likewise, we can also draw the v1 vector. It's going to be, let's say this is going to be in this direction. Also the main point over here is it's also going to go from the same origin point. So we can directly tell, let's say there's a point called 1 2 3. This is a v1 vector. So over here we need to find the orthogonal projection from this v1. So the task we need to do is, let's say this is a point 1 2 3. So here we are going to draw a right angle, a perpendicular line for v2. So this is the main thing. They are asking about the scalar component of this one, which simply means we need to find the magnitude of this one. So in this case, some might think whether this point, which means the 2 minus 1 3, will coincide with this one, this point. So there will be a question. Most of you have this one question. The thing is, it might be the same, but however in this position it won't be the same. So I'm going to repeat this. we need to find this one, we need to find this magnitude, because they are asking only about the scalar component of this orthogonal projection. Orthogonal projection, they are mentioning the order from V1 on V2, which means we need to draw the orthogonal projection from this point to this line. If you draw to the line, some might think we need to find this this magnitude. If we knew the point, we can directly use some rules and find that. So some might taken this point as this one. So is it the truth? Whether it would be the same, it might be, but in this case it's not. How to check this? If you knew the value, or you knew the direction vector of this line, if this is a point over here, let's say this point is 2 minus 1 3, you can find this direction vector also. After that, use the dot product. If you find the answer as 0, which means the angle between these two vectors would be 0. In this case, if you do that, you won't get 0, so forget that. So here we need to find this point. So what can we do from this? So over here, actually when you are using the vector questions, the most of the question will have the dot product or cross product. So here we are going to check that whether it's going to have the dot product or cross product. So let's say this is an angle between these two vectors theta, v1 and v2. The angle between these two vectors would be theta. So here we need to find this length, which simply means it's going to be as we knew the length of this one, we can directly tell it's going to be v1 sine theta. So let's write like that, v1 sine theta. Be careful, we are going to take this magnitude, v1 sine theta. So the next question is how to find this v1 sine theta. Have you ever studied any product, dot product or cross product, which will give the result of sine theta? Yes, we can remember that if we take the cross product between any two vectors, we will be getting an answer in the sine theta. So I'm going to take the cross product. So over here I'm going to take that v1 cross v2. If I write like this, I'm going to get the result of v1 into v2 into sine theta into a, which simply means the direction vector of this cross product. However, in the case we are going only to find, they have only asked to find the scalar component, which simply means we can neglect this. So which means we need to find v1 sine theta. From this, if we subject the v1 sine theta, we will be getting v1 cross v2 over, I'm going to write that component is going to be v2. We need to divide it by this. So here we need to find what's meant by that v1 cross v2 over here. After that, we need to find the magnitude of v2. Otherwise, it would be a little bit difficult to continue this. So the problem over here is what's the value of mod of v2. So in this case, remember, when you are finding this mod of v2, we can use these 2 points, which means 2 minus 1 3 and 0 0 0. Some might get confused. How can we use that? Because in the v2 direction we are only using this one, this length only, this part only. If we consider the magnitude of v2 from this point, we are going to get a little bit longer than this one. This length is this length, if you use this length, it's going to be longer than this one. So whether we can use that. The point over here is these are not same. Yes, that's the truth. However, in this case, when we are finding the cross product of v1 v2, we are going to use this v2 as this length from this one. However, if we use that, we are going to get the answer for this one, which simply means when we are considering this triangle, we are using the cross product for this vector and this vector, which simply means we can use the magnitude of this vector as we are going to use the vector of this, which is having this magnitude over here. We can directly divide it by this. So the point over here is some might get confused. actually we are using the, when we are using the geometry, basic geometry, we are using only this triangle, which means v1 sine theta. So we need to divide the vector v2, the magnitude of v2 would be this one. So be careful. Actually we are not using that geometry directly, we are using the cross product. If we use that, when we are using this v2 vector, we are going to use that v2 vector directly, which is having this length. So we need to divide it by this magnitude. So don't be confused. Even I get confused when I do that first video recording. I get confused and stop this one. So this is the main point. Some might get confused when you are doing at your exam. So I'm going to find the cross product of v1 on v2. Most probably you can do this easily. Let's say it's going to be in this size. You need to put I, j, k, and if I consider v1, so remember this order. First of all, we need to write the v1 1 2 3, and the v2 would be 2 minus 1 3. After that we need to simplify this. If I do so, I'll be getting, let's say this is I, j, k, and if I consider this 2 3 6 minus 3 would be 9, minus, if I take this one 3 minus 6 would be minus 3, so it's going to be plus 3j. If we consider the k, minus 1 minus 4 is going to be minus 5. So remember, we need to use only the magnitude. So how to find the magnitude of this? You can directly tell the magnitude of this v1 into v2 cross product, which means this is a vector, it's going to return this vector. We need to find the magnitude of this vector. We can directly tell it's going to be the root of 9 squared plus 3 squared plus minus 5 squared. If you simplify this, you are going to get sorry, I need to put like this one v1 v2 over here, because we are neglecting this direction vector. So if we do so, we can find the answer for magnitude for v1 cross v2. After that, we need to find the magnitude of v2 using this one. It's going to be, let's write that also. So if I write this one, v2 root of 2 squared plus minus 1 squared plus 3 squared. So you will be getting the answer for the magnitude of v2. After that, you need to substitute over here, and you will be getting the mod of v1 sine theta, which is the orthogonal projection, the scalar component of orthogonal projection of v1 on v2. I hope this video would be clear for you. If you have any doubts, please comment it below. I try to solve that also. Please subscribe, expert, tutor. Let's see in another video. Thank you.